Essay 3.4 Radians, Arc and Sector. With this section, we need to talk about the radian measure and then the arc and sector and how to measure an angle in terms of the degree and radians. So first thing that we need to talk about is the radian measure. How to measure radians and how to convert from degree to radian or how to convert from radian to degree. Okay, so let's talk about a circle in terms of the degree first. Okay, so let's say we have a circle. Let's say we have a straight line that goes through the origin of the circle, and the angle formed on top of the straight line is measured as 180 degrees. So this is how you measure the angle. Okay, then let's talk about this measurement of angles in radian. Okay, so I'm going to identify a sector on this circle first. Okay, so I got a sector. So sector is a division, or you can say that it's a part of the circle that has a shape of pizza slice. That's a sector. Okay, so when we have a sector, we always have an arc. So this is the red part is arc. Okay, so this red part is arc. Okay, and the arc length, the measure of this arc, or the length of this arc is called arc length. Okay, so if I say the radius is r, if the circle has a radius of r, and then if the arc length is also r, then since the arc length formed by this angle theta is the same length as the radius, then this angle is said to have a measure of 1 radian. And the radian has a symbol of the c, so we can also write the 1 radian as 1 small c. Okay, so once again, if we have a sector, okay, let's say we have a sector. Okay, this is sector, your green part. Okay, the pizza slice is sector, and if the sector has an angle of theta, and if its radius and then arc length has the same length, then we can say that the theta is the 1 radian. Okay, and 1 radian is approximately equal to 57.3 degrees. Okay. However, what's important is that we need to know how to convert from degree to radian and from radian to degree. And you can see that 57.3 is not a great number to use. So we have to come up with a conversion factor to convert from radian to degree to radian. So we're going to use a circle, or let's say semicircle, to derive that conversion factor. Okay, so let's say we have a semicircle. Okay, so I'm going to draw semicircle here. So let's say we have a semicircle. Okay, and we have its center here, and we can say that the r is its radius. Okay, then in this case we have arc length equals to pi r. Then we can say that there are pi radians in a semicircle. So from this statement, we can also conclude that the pi radians is equal to 180 degrees. Okay, so since we know that pi is equal to 180 degrees, we can use this as a conversion factor. So if we want to convert from the degree to radians, then we need to multiply by the pi over 180. So if we have a degree, right, then if we multiply by pi over 180, then we can have to have the number in radians. Same thing, if we want to convert from radians to degree, then we have to multiply by conversion factor 180 over pi to have the angle in degrees. Okay. So this conversion factor, so this is like conversion factor or conversion equation or formula, is not actually not in formula booklet. So you have to remember this. Okay. Let's do an example. We have example here. The question A says that we have to convert 126.5 degree to radians. Okay, so in order to do this, we have to multiply 126.5 degree by pi over 180, which is the conversion factor, right? Then we get approximately 2.21 radians. Same thing with the question B, since we need to convert from 5 pi to degree, we have to multiply by 180 over pi. 180 over pi is again the conversion factor, right? Then we get about 900 degree. Okay, so we now have discussed how to convert from degree to radians and radians to degree, right? So now we need to talk about the arc length and sector area, because we have learned the area of the or circumference of the circle in previous math classes. And in the IB curriculum, we also need to know how to find a fraction of the area or circumferences. Okay, the first thing that we need to learn to fulfill this requirement is sector. Okay, so let's talk about sector first. I already told you sector is the part from a circle that has a shape of the, so this is the sector, the green part. Okay, with the sector, we always get a piece called arc. So arc is this part here. So this is an arc. Okay, and we can also measure the arc. So when we measure arc, we call it a length of arc or the arc length. We also, like with the sector, we also get an angle, right? So when the angle is given in degrees, we can still use the formula such as L equals, so L denotes the arc length, equals theta over 360 times 2 pi r, or we can also calculate the area by using this formula. However, if an angle is measured in radians, the formula becomes much simpler. So theta, the angle, measures how many times longer the arc length is than radius, right? Then we can say that the arc length is same as theta times r. Okay, and since there are 2 pi radians in a circle, so arc sector is same as of a sector there is always equal to theta over 2 pi times area of a circle, right? Then we can also say that the area is equal to theta over 2 pi times pi r squared. Then with the simplification, we can say that the area is equal to 1 over 2 times angle times r squared. Okay, and it is very important to note that these two formulas are actually given in your formula booklet. Okay, so you don't have to memorize it. However, you also have to know that when you use these two formulas, the angle theta given is in radians. Okay, so let's do an example. So here we have x and y that are the centers of the circle containing the two arcs AB that is shown here. Okay, we first have to find the length AX. So we are talking about this part here, AX. And then you can see that actually this is the part of a right hand triangle. Okay, so since x and y are the centers, okay, it is possible to draw a circle using y as its center. So let's try to match the circle here. So means let's get rid of this green part. Then we can say that this line here and this line here are radius, right? Since this part is 16, we can also say that the length from the B to Y is also 16. Then we can simply use the Pythagoreans to identify the length of the AB, right? Then you can say that the length of the AB is same as square root 16 square plus 16 square, right? 16 square plus 16 square is same as square root 512, which is equal to 22.6274. And since we need to find the length from A to X is same as half of the AB. So the answer is 22.6274 divided by 2. So it is same as 11.3137. So its length is approximately 11.3 millimeters. So question B, we need to identify the perimeter of the shaded crescent. So means we need to find the perimeter of this crescent, right? So I just highlighted with the red. So we first have to identify the length of this part here. I'm highlighting with the yellow. Okay, so we need to find this part here. And this is half of the circle, right? We already have discussed that X is the center of a circle. So means we can have a circle like this. And this A to B is half of the circle, right? So we can say that we need to find the half of this circumference of a circle. So we can do half of circumference of a circle, right? Plus we need to find the arc length, which means this part here. Okay, let's highlight it with the pink. We need to find this part, right? And this is actually the arc length of this sector, right? So we're going to find the arc length of the sector. Okay, so arc length of the sector. Okay, so half of the circumference. So circumference of circle is actually, the formula is 2 pi r. So since we need to find half of it, we're going to do 2 pi r divided by 2 plus the arc length of this sector. So arc length is pi, or the angle r, right? So we're going to do angle plus r, no, or angle times r, right? So let's do angle times r. Okay, so 2 pi r is 16 divided by 2, and the angle of the sector is actually 90 degree. Okay, So since we are using the formula in radians, we have to use the 90 degree in radians, which means using the conversion factor, we know that the 90 degree is actually same as pi over 2. So we're going to do pi over 2 times 16. Okay, then we get 16 pi plus 8 pi, which is equal to 24 pi, right? Then this is your answer for C. Oh, for B. Question C. We need to find the area of the crescent. So we are looking to find the area of the crescent. So means we're looking for this blue part here. And you can see that this blue part is actually, let's clear this part a little bit up. This blue part is actually a semicircle minus this part here. Okay, then what you can do is we can first identify the area of this semicircle. Okay, so since the area of the circle is pi r squared, we can do pi r squared divided by 2, which is the area of the semicircle, or the area of the semicircle, yeah. And we can subtract this part here, the blue. I'm circling right now. If we subtract this part, the one that I'm coloring right now, then we can calculate the area of the crescent, right? And you can say that this dark blue colored part is actually part of the sector. So if we calculate the area of the whole sector, okay, so if we calculate the area of the whole sector and subtract this right angle square part, then we can calculate this dark blue part, right? Then let's identify the area of the sector, which is 1/2 angle times r square, and we're going to subtract this triangle part, right angled triangle part, which is 1/2 times 16 times 16. Okay, we can do pi 16 square over 2 minus 1/2. The angle is 90 degree, and we know that 90 degree is pi over 2 already. So we're going to do pi over 2 times 16 square minus this part. 1/2 times 16 times 16. Okay, so if we do this, we get 128 pi minus 64 pi minus 128. Okay, then we get the final answer, 73.0619. Then the answer is 73.1 approximately. Okay, and it's going to be millimeter square in terms of unit. Okay, so let's do some IB questions. So the first question is the IB question from the specimen paper. So we know that we have a diagram here showing a part of the circle with the center O and the radius 4. That means this side is also 4, and we have a chord AB. So we have a chord here AB, and it has a length of 5 centimeter, and the angle between here is actually a theta. Okay, it's given as theta. And question A, we need to find the value of angle theta and give our answers in radians. Okay, so let's try to find the angle first. This is actually a triangle, right? Yeah. So I'm going to redraw the triangle. Okay, so I have a triangle. Okay, and I know that this side is 4, this side is 4, and this side is 5, and I know that there's angle theta. Okay, you can see that this is an angle that has no 90-degree angle. So it means we can use the cosine rule, which is we can do c squared equals a squared plus b squared minus 2ab times cosine c. Okay, then let's say we have a point C, A, B, then theta is actually angle C. Then the 5 is small c or side C, right? And we can say that this 4 is side A, this 4 is actually side B. Then we can substitute all the numbers into the formula. So 5 squared equals 4 squared plus 4 squared minus 2, 4 times cosine angle theta. Okay, then we can solve for the angle theta. So cosine theta is equal to 4 squared plus 4 squared minus 5 squared over 2 times 4 times 4. So this is can be recalculated using cosine inverse. Using cosine inverse, then angle theta is 77.3644, and since we need to keep our answers in radians, this is approximately equal to 1.35 radians. Okay, then question B, we need to identify the area of the shaded region. So let's clear this diagram a little bit. Okay, so shaded region is actually part of the circle, and we know that this is the incomplete circle. So I'm going to draw the remaining part of the circle. Okay, then we can see that there's an X sector, right? Then, so there's actually sector. Then what we need to do is we have to first identify the area of the circle and subtract this area of sector. Then we can identify the area of the shaded region. So we're going to do area of the circle first. So means pi r squared minus area of the sector, which is 1/2 times angle times r squared. So we do 1 pi 4 squared, so radius 4, right? And 1/2 our angle 1.35 times 4 squared. Then we get our final answer. So using your GDC, you can find that the shaded region of the circle is equal to 39.4655. So it's approximately equal to 39.5 centimeter cube. Then next question. Question number 2. We have IB question from the example paper. So this diagram shows part of the circle with the center O and radius 3. So, and we have A, P, B on the circumference of the circle. So we have chord AB, this part, that has a length of the L. So this part has the length of the L. Okay, and the A or B that has an angle theta radians. Question A, we need to first show that the arc APB has a length of the 6 pi minus 3 theta. So we need to identify that the APB. So we need to show that the arc APB, so we are referring to this green part here, has the length of the 3 pi minus 3b. Okay, we know that then since we need to find the arc length, right? The arc length, the formula is arc length formula is angle times r. So we first need to know this angle here, right? So this angle here is same as, since the full revolution of the circle is 2 pi. So let's draw here. So full revolution of the circle is 2 pi, right? Then the angle from here to here is same as 2 pi minus theta, which is this part, right? So we can say that the arc length APB is equal to 2 pi minus theta times the radius 3, which is given in the question. Then we can say that the arc APB has length of 6 pi minus 3 theta. Question B, we need to show that the L is equal to square root 18 minus 18 times cosine theta, right? So L is referring to this purple part here, right? Or let's just clear this diagram a little bit off, okay? So we know that L is equal to this line AB, okay? Since we know that L is referring to the line LB, we can rewrite like this, right? Then we also know that this AB, with this line AB, we can actually draw a triangle, right? We can actually draw a triangle here. So let's clear this part out, and I'm actually going to draw a triangle on here. So we can draw a triangle like this, okay? Then we can say that if I renumber all the things here, I have A point, B point here, and the C point. That means L, line L is actually same as side C. And this side here is same as side A. This side is same as side B. Okay. Then using the cosine rule, we can say that C squared is actually equal to B squared plus A squared minus 2AB times cosine C. Okay. Then we can also say that the line AB is same as L and is same as C. Then let's try to identify the C first. So C squared is equal to B, which is radius, so it's a 3, right? The radius is 3, so B is 3 and A is also 3. So B squared is a 3 squared. A is also 3, so A squared minus 2, 3 times 3 cosine angle theta, right? Then we have C squared equals 9 plus 9 minus 18 times cosine theta, which means C is equal to 18 minus 18 times cosine theta. So since we know that C is equal to square root 18 minus 18 times cosine theta, and C is also same as L, we can say that the L is also same as square root 18 minus 18 times cosine theta. Let's talk about question C. Then question C, we know that arc APB is twice the length of the chord AB. We need to find the value of the theta. With the question C, we know that the arc APB is same as twice of the chord AB, right? So we can set the equation like 6 pi minus 3 theta equals 2 times square root 18 minus 18 times cosine theta. So we have an equation, right? So this is like actually we studied this type of question or this type of equation in the previous section with the topic 1. But when you have two equations equal to each other with the same variable, we can identify the unknown variable by finding intercept. Okay, and this is a paper 2 question. So the simplest way to solve the questions like this is by finding the intercept of these two equations using your GDC. Okay, so you can put this one into your L1. So this first part of the equation is your first equation, so it's going to be equation L1, and the second part as your second equation. Actually, your GDC will say is Y1, right? Your second part of the equation is a Y2. Then you find intercept, then you got your answer. Then your answer is 2.49.